Today we are going to learn about sentiment analysis with Python, a practical guide. We'll explore how to perform sentiment analysis, a vital aspect of natural language processing, and build a simple model using Python and its libraries. By the end, you'll have practical skills to analyze text data for sentiment insights. Welcome to our comprehensive guide on sentiment analysis with Python. Sentiment analysis, a subset of natural language processing, involves determining the emotional tone behind a body of text. It's crucial for understanding customer opinions and trends, playing a significant role in market analysis, customer service, and product development. In this video, we aim to equip you with the skills to perform sentiment analysis using Python. We'll cover everything from the basics to building a simple yet effective sentiment analysis model. Sentiment analysis is transforming how industries interact with data. Companies harness it to analyze customer feedback, helping them tailor products and services to meet consumer needs. For instance, by analyzing social media posts, businesses can gauge public sentiment towards a product, aiding in market research. Furthermore, sentiment analysis is a powerful tool for brand monitoring. It helps companies detect and respond to potential crises quickly. In addition, it can inform product improvements by highlighting the strengths and weaknesses perceived by consumers. Lastly, it enables businesses to conduct competitor analysis by comparing sentiment trends across different brands.
There are several algorithms used in sentiment analysis, each with its own strengths. Rule-based methods rely on a set of manually created rules to identify sentiment. These methods are straightforward but can lack nuance. Machine learning techniques, such as support vector machines and neural networks, learn from data to classify sentiment, allowing them to handle more complex language patterns. Lexicon-based approaches use a predefined list of words associated with positive or negative sentiments. Hybrid models combine these methods to balance accuracy and complexity. Selecting the right algorithm depends on factors like data size, language complexity, and desired accuracy.
TextBlob is a popular Python library for processing textual data, offering simple APIs for common natural language processing tasks, including sentiment analysis. It's particularly praised for its ease of use and efficiency. TextBlob provides functionalities to extract noun phrases, tokenize text, and detect language, among others. For sentiment analysis, it uses a pre-trained naive Bayes classifier to estimate the polarity and subjectivity of a text. The polarity score ranges from -1 to 1, indicating negative to positive sentiment, while subjectivity measures the amount of personal opinion in the text. An example use case is analyzing customer reviews to understand overall sentiment towards a product or service.
VADER, or Valence-Aware Dictionary and Sentiment Reasoner, is a sentiment analysis tool specifically tuned for analyzing sentiments in social media text. It is lexicon and rule-based, designed to capture the nuances of social media communication. VADER is capable of understanding emojis, slang, and acronyms, which are prevalent in social media platforms. It's easy to use. After installing the library, you can quickly start analyzing sentiments of tweets or comments. VADER outputs a compound score that summarizes the overall sentiment, along with positive, negative, and neutral scores, making it ideal for quick insights into social media sentiment.
Preprocessing is a critical step in sentiment analysis, as it prepares raw text data for analysis. Effective preprocessing can significantly improve the accuracy of sentiment models. Common techniques include tokenization, which breaks down text into individual words or sentences, and stemming, which reduces words to their root form. Removing noise such as punctuation, numbers, and unnecessary symbols is essential, as is eliminating stop words like then is, which add little value. Text normalization involves converting text to a consistent format, such as lowercasing all words. These steps ensure the data is clean and suitable for analysis, ultimately enhancing model performance. Building a sentiment analysis model involves several key steps. First, it's essential to understand the model's architecture, which typically includes input layers for text data, processing layers for sentiment classification, and output layers for results. Choosing the right dataset is crucial. It should be representative of the text you'll be analyzing. Python provides several libraries, such as scikit-learn and keras, to implement these models. The next step is training the model using labeled data, allowing you to learn patterns associated with different sentiments. After training, the model is tested on new data to evaluate its accuracy, with adjustments made as necessary to improve performance.
Evaluating the performance of a sentiment analysis model is vital to ensure its effectiveness. Common evaluation metrics include accuracy, precision, recall, and the F1 score. Accuracy measures the overall correctness of the model, while precision and recall provide insights into how well the model identifies positive or negative sentiments. A confusion matrix is a valuable tool for visualizing the model's performance, showing the true positives, true negatives, and false negatives. The F1 score, a balance between precision and recall, is particularly useful when dealing with imbalanced datasets. By analyzing these metrics, you can identify areas for improvement and refine the model to boost its accuracy.
Despite its usefulness, sentiment analysis faces several challenges. One of the primary difficulties is handling sarcasm and irony, where the literal meaning of words doesn't reflect the intended sentiment. Contextual understanding is another challenge. Sentiment can vary depending on the context in which words are used. Language and cultural nuances also play a significant role, as words may carry different sentiments in different cultures or languages. Data quality issues, such as noisy or biased datasets, can further complicate analysis. Additionally, models can inherit biases from the data they're trained on, highlighting the importance of careful data curation and model evaluation to mitigate these limitations. For those looking to delve deeper, advanced sentiment analysis techniques offer exciting possibilities. Deep learning approaches, such as recurrent neural networks and transformers, have revolutionized the field by providing more nuanced sentiment understanding. Transfer learning, which involves fine-tuning pre-trained models like BERT or GPT-3, allows for more accurate sentiment analysis without needing vast amounts of data. These models, trained on extensive datasets, can capture complex language patterns and contextual information. As the field evolves, we can expect continued advancements in model accuracy and efficiency, driven by innovations in deep learning techniques and the growing availability of high-quality datasets. Ethical considerations are paramount in sentiment analysis. Privacy concerns arise when analyzing personal data, emphasizing the need for consent and transparency. Users should be informed about how their data will be used and have the right to opt out. Bias in sentiment analysis, often stemming from biased training data, can lead to skewed insights and unfair outcomes. It's crucial to ensure data diversity and fairness in model development. Furthermore, ethical data usage involves respecting data ownership and avoiding misuse. The insights gained from sentiment analysis can significantly impact decision-making, underscoring the importance of ethical practices to maintain trust and integrity. For those interested in expanding their knowledge, numerous resources are available. Books such as Natural Language Processing with Python offer comprehensive insights into NLP and sentiment analysis. Online platforms like Coursera and edX provide courses tailored to various skill levels. Engaging in open-source projects on platforms like GitHub can offer practical experience. Community forums such as Stack Overflow and Reddit are valuable for problem-solving and networking. Lastly, staying updated with the latest research papers and publications can provide insights into emerging trends and techniques, ensuring you remain at the forefront of sentiment analysis advancements.
As we conclude, let's recap the key points we've covered. We've explored the fundamentals of sentiment analysis, its applications across industries, and the various algorithms available. We've also delved into practical implementation using Python libraries like TextBlob and VADER, emphasizing the importance of preprocessing and evaluation. While sentiment analysis offers valuable insights, it also presents challenges, particularly in handling complex language and ensuring ethical practices. We encourage you to explore further, harnessing the power of sentiment analysis to drive informed decisions. Thank you for joining us on this journey, and we wish you success in your sentiment analysis endeavors.